Here's page 141. Now we're on page 142. Piecewise functions. Our functions represented by a combination of equations. The rule for piecewise functions is different for different parts or pieces of the domain. For example, movie ticket prices are often different for different ages. Everybody remember going to the movies? It's been a long time since I've gone to see a movie in the theater. Back in my day. No. Man, I didn't really think about that until just now.
I don't even remember the last movie I saw in.
Agreed.
Mine was the new Jazzy.
Oh, I know what mine was. Mine was Frozen 2. I remember that now. Okay, a special kind of piecewise function that is constant for each interval of its domain, such as ticket price function, is called a step function. And for the least shocking thing that you've heard all day, it's because it resembles a set of stairs. Right? What? It's called a step function because it looks like steps. Okay, so our first example, write a piecewise function for the admission prices given on the graph. Okay, so let's talk about what this graph says. Yes.
I had no clue what was going on.
Right? Now you'll know for the next time you take it. Hey, this will help you though. This will help you. This will help you. Okay. All right, so what does this line right here mean? Where does it start? Starts at 0 and it goes up to what? Age 7, right? And it's $5, right? So wouldn't that mean that anybody between the ages of 0 and 7 has to pay $5? Okay, what about if you're 7 years old? Is it including 7 right here? If it's an open circle? Nope, that means it's going to be up here. So once you turn 7, you have to pay, good grief, $20. Is this like the IMAX or something? Jeez.
Whatever this is, it's open.
Right? Agreed. Okay. Ticket to heaven. All right. So once you turn 7, you get to pay $20 up until you are age 12. But when you turn 12, you have to start paying, holy moly. Is that $45? Sheesh. Oh my. All right. So to write this as a piecewise function, we have 3 pieces, right? So we're going to write 3 pieces of an equation. So our first one is going to be $5 if you're between the ages of 0 and 7. So 0 less than A for age, less than 7. So if you're between 0 and 7 years old, you're going to pay $5. What's my next ticket price? $20. And you'll pay $20 starting when you're 7 years old, less than or equal to your age up until 12, right? And then our most ridiculous ticket price of $45 for when you are greater than or equal to 12 years old. Starting to sound like what? Maybe. So how much would a 9-year-old have to pay? Why? Why $20? Because that's where they are. Because you're between 7 and 12, right? So someone who's 4, my child, she would have to pay $5 because she's between 0 and 7. I don't know. They can do chores and earn money. Okay, someone who's 31, like me, aka old, they would have to pay the $45. Oh, I am old. Sad. All right. There's our most basic piecewise function. Are any of y'all going to pre-cal next year?
No.
You'll do Piecewise in pre-cal if you're doing pre-cal next year.
I'm not even going to college.
I'm pretty sure they do this in college algebra also.
I'm not even college.
What are you doing?
AP stat.
AP Stat? Nice. I don't know if she does piecewise functions. No idea. Okay. Example 2, evaluating piecewise functions. Okay, so to evaluate each one, you have to figure out which piece the x value falls in. Okay, so just like last time, we had to figure out which step you were on to determine how much money you were going to have to pay for your ticket, right? We're doing the same thing here. We just have to figure out which piece we fall into. Okay, so f of -3. Is -3 less than -1 or greater than or equal to -1? Less than. So since it's less than, it's going to be in this piece of our piecewise function. So I'm going to take -3 and plug it in right here for x. So -3 minus 4. What is -3 minus 4? -7. I also need to find f of 4. So if I go to plug in 4, is 4 less than -1 or greater than or equal to -1? Greater than or equal to. So it's going to be this piece of the function. So I'm ignoring this one on top, and I'm looking right here. So I'm going to plug in 4 for x. 3 times 4 minus 1. What is 3 times 4? 12, and 12 minus 1 is 11. Okay, next I have f of -1. Is -1 less than -1 or greater than or equal to -1? Greater than or equal to, because it's that or equal to -1. So f of -1, I'm going to plug in -1 to the second equation. So 3 times -1 minus 1. 3 times -1 is -3 minus 1 is -3 minus 1. Thank you. Thought I was going to have to call on somebody. Ruin their day. Okay, skip B for a second and do part C. Figure out which piece it falls into, and then plug it into the correct piece. Okay, compare with your neighbor. See if y'all got the same thing. You don't remember the exponent. You could type it in your calculator. That's fine. All right. Miles, what'd you get for the first one? F of -1.
5.5.
Yep. And Cheyenne, what'd you get for the second one? 15. You should get 1/15. Very nice.
Very right, this doesn't.
Yeah. Okay. On this last one, we're finding f of -3, f of 1/2, and f of 1.5. So again, you just have to figure out which piece it goes into. But what you'll notice about this one is there's no x value to plug it into. So it's just going to equal whatever this value is here. Okay. So f of -3. I'll explain in a second. Okay, is -3, or which one of these pieces does -3 fall into? Is it between -2 and -1? Is it between -1 and 0? Is it between 0 and 1? Or 1 and 2? Nope, so it's undefined. It does not exist on this function. What two numbers is 1/2 between? It's between 0 and 1. So if it's between 0 and 1, then your function value is just 0. You don't have to plug 1/2 in anywhere. All you're doing is looking to see which piece it falls into. Well, what two numbers, let me do this. What two numbers is 1.5 between? It's between 1 and 2. So f of 1.5 is going to just be 1. Okay, this one is similar to the one we did on the front with the ticket prices. It's been a long time since I've heard that. Thought we were past that. All right, here we go. Now we're going to write some equations like we did in the beginning, but more complicated. This is another piecewise function. It has 3 pieces and it's really ugly, right?
I like that.
You kind of like it? It's symmetrical. That's true. All right, so we're going to do all 3 pieces because there's 1, 2, 3 pieces of this graph. So let's start up here. What's the equation of this line? Y equals 4. So I have the y equals here, so it's going to equal 4 if, okay, looking at your x values left to right, where does this line start? What x value? -2. It's a closed circle, so it's going to be x less than or equal to -2. Okay, skip the middle one for a second. Look at this one down here. If it's a horizontal line, it's going to be y equals a number. Well, what number does this one equal? -3. If x is greater than or equal to what x value? 2. All right, so this middle one, let's start with the domain over here because that's the easiest part. It starts at -2 and goes all the way to +2, right? So this is going to be if x is between -2 and +2. Since it's open circles at the end, it's just going to be less thans. It's not going to be or equal to's, right? What's the equation of this line? Yep, your slope is -1/1. What's your y-intercept? 0. So isn't that -x? You have written the equation of that really ugly piecewise function. That's it. It was only a little bit miserable. That's good.
Yeah, I'm not completely lost. That's something, I guess.
Good.
Perfect.
Okay, try part B with your neighbor.
Side by line.
This one only has 2 pieces. This one only has 2 pieces. Start with the domains.
Yeah, I was feeling it for a second. I was just.
Start with the domain.
Yeah, I was feeling good about my going. Hiking now.
Hey, y'all are supposed to be working this on.
Yeah, Chase.
Mhm. All right, well, let's all wait on Miles. All right. On this one, we start with the domain. This first piece starts at -1 and is everything to the left of that, right? So that's going to be x less than or equal to -1. And this piece starts at -1 and is everything to the right of that. So x greater than -1. Okay. If this line were to continue going this way, what would the slope be? Down 1 over 2 is going to be -1/2.
Yeah, I thought I was doing all right.
So down over 2 would put another point there, which means my y-intercept is going to be right here at 2.5. So plus 2.5. That's really hard to see.
Yeah, I.
Here, let me put this over here. It's hard to see. Sorry. I'm going to write the same thing. Don't erase yours. Okay, so it was -1/2 x plus 2.5 if x was less than or equal to -1. The other one was greater than -1. What? Okay, so if I were to continue this line right here, this direction, then I would use my slope to plot another point. Down 1 over 2, down 1 over 2, which means it would go through this point right here of 2.5. So that would be my y-intercept. That's the y-intercept, right? It's where it crosses the y-axis. Good. Okay, the second piece is easier because you can actually see where it crosses the y-axis. So my y-intercept is 1. My slope is up 2 over 1. So 2x plus 1. Okay, if you wanted to check your equation to make sure that it was correct, you could find another point on here. So like this is the point 2, 4. Nope, that's 5. 2, 5. So if you plugged in 2 here, 2 times 2 is 4 plus 1 is 5. So that would be correct. Over here, if you wanted to do -3, you plug in -3. It's Negative 1.5 plus 2.5 is 4. So that side is correct also. All right. Nope. Almost.
We're not gonna get off ready.
Page 143. This is the last page of notes for today. Just remember, this could be worse. It could be geometry.
Yeah.
Right? I know, I agree. All right, graphing. Doesn't that look like fun? For sure. All right.
Yeah.
Okay, so we're going to take this a piece at a time. So I'm going to take this negative x plus 2, and I'm going to ignore the rest of it. Okay, this number right here in our domain, it says x is less than 0. I'm going to take this 0 and plug it in. Okay, if I do that, it's going to be negative 0 plus 2. So just 0 plus 2, which is 2, right? It doesn't matter. We're not having that argument right now. Okay, so this point, 0, 2, is going to be my starting point. Now, is it going to be a closed circle or an open circle?
Open.
Why? Because there's not an equal to. So I'm going to go to the point 0, 2, and I'm going to put an open circle. If we're doing x less than 0, is that going to be to the left or to the right? Why? Because that's when all the numbers are going to be less than 0, right? Over here on the left is going to be less than. Okay? So when I draw my line, I need to go to the left because we are less than. It's on the left side of my graph. So from this starting point, my slope is negative x. Well, normally you would go down 1, right 1, but am I going to the right? No, I'm going to the left. So I'm going to go up 1, left 1, and draw my line to the left because less than is to the left. Should I say left more often? You have successfully graphed the first piece of this function. Now I'm going to ignore everything I just put in pink, and I'm going to only look at this stuff in blue. And I'm going to start it the same way. I'm going to use this value right here and plug it in for x. So 2 times 0 plus 1 is 1. So 0, 1 is my starting point. Is it going to be a closed circle or an open circle? Closed circle, why? Because it has the or equal to. Now that I have my starting point, I'm going to use my slope. If we're going greater than or equal to, is that to the right or to the left? It's to the right. I can't go left because I already have stuff on the left. I have to go to the right. So from my starting point, I'm going to go to the right, and I'm going to go up 2 over 1. And there you go.
That's all that's it.
That's it. It's graphed.
Oh,
You graphed both pieces.
glad I don't have to make a table.
You don't have to make a table.
Yeah.
Okay?
Take it.
No, try the next one.
Whoa, bro, why do I got distractions every time?
It's the worst. Okay, but fraction slope, come on now. It's rise over run, you can do it. Do you want me to do the fraction part with you? Would that make you feel better, Miles?
Yeah. Sure.
Fine. Okay, less than is to the left. Take the 1 and plug it in. So 1/2 times 1 is 1/2 plus 3/2 is 2. So your starting point is going to be the point 1, 2. Closed or open circle? Okay, if your slope is 1/2, that's rise over run, and we're going to the left. So starting here, normally you would go up 1 to the right 2, but we're not going to the right, we're going left. So we're going to go down 1, left 2. Now you do the right side.
Oh, no. Oh.
All right. Can check yours with mine. Just looks like a very lopsided V, right? The good news is they could be way worse because I took out all the ones with parabolas. You're welcome.
Like all of them, or we gonna eventually see them?
Nope, I took them all out. We didn't have time for that. All right, so you should have a green paper that I just gave you, which is homework 52. It doesn't say that on there. It says EOD Piecewise Worksheet. Okay. I haven't worked it yet, so I haven't posted the answers, but I will do that now. I will work this and then post the answers. So that's all we have for the rest of the time. Unless you're working on a test or a quiz, then finish that and then do this.